trying to pull this cable, and I'm on the fourth one, so I only have to pull 4. So I'll be glad to have this job done because I'm kind of smushed up like a little bridge troll under here. It's not very comfortable. Okay, this is the next video in our series on DIY installation of a solar electrical system, and today we're going to talk about the combiner box. What's a combiner box? It's an enclosure that allows you to tie all of your cables from your solar panels into one tidy little box, isolate all of the strings using a breaker, control the panel strings with the breaker, and basically allows you to consolidate all those cables so that you have one positive and one negative output to run to your charge controller. It's just a really tidy way of making things neat and allowing you to ground your system and add surge protection devices and things like that. It's the ideal way to go. So what is a combiner box? This is a combiner box we're using. We're using 2 of these because our array is actually split into 2 different arrays so that we can expand it later. This is the Midnite Solar MNPV6 6-position combiner box. And when I was researching these online, I saw a lot of people connecting these up, but I never saw someone actually take it out of the box. It doesn't come all set up. You have to kind of assemble it, and so that's what I was going to show in this video, and then we'll wire it up to our solar panels. Now, the way we've designed our solar array, we have 6 strings of 3 panels each, and so we need 6 positions in a combiner box, basically 6 breakers, 1 for each string. Each one of those strings maximum short circuit current is just under 10 amps, so we're going to use 15 amp breakers. So if these trip, we know something's going bad with one of those strings. These are 150 volt 15 amp DC breakers made specifically for like solar panel circuits. Let's see what's in the box when you first get one of these. Got your instructions. There's a lot of different ways you can wire these. Like I said, this is a 6-position box. You can actually split the bus bar in half and run 2 separate systems in one box, but we're not doing that. We're using half of one of these boxes, and we're using 2 boxes, which gives us the ability to double our system later. So each combiner box will go into one charge controller. Our system is going to have 2 charge controllers. So this is the box. It's just a pretty standard electrical enclosure. When you get it, take the screw out. Don't lose this lock nut. All right, so we got our screw out. Now we want to lock that. And this is a standard diagram of a pretty simple wiring configuration. This is actually exactly how we're going to be wiring ours. Each one of these breakers is connected to 3 panels wired in series. Remember, when you wire in series, you're increasing the voltage and the amps stay the same. So each one of our strings will be putting out probably 8 amps at close to 93 volts. And so our breakers are sized 150 volts, 15 amps. So in this diagram, this is going to be the positive bus bar, and this is going to be the negative bus bar, where our solar panel leads will come in. Each positive will go to its own circuit. Each negative will go to this common bus bar. And then we'll have a larger cable going out from the common positive to our charge controller, and a larger negative going to our charge controller. And then all of these will be grounded together to a common ground bus bar, and then we'll run a cable to a ground cable to a grounding rod. And that's kind of it. All this does is ties all of your panels together to one common cable, so it's easier to manage. So to take this dead front off, you kind of have to pry it up. And there are 4 tabs at the bottom here. then you can tilt this up. Now inside, there's a label sheet. Most of these have been already applied because they've set it up to a certain extent. Let's take this off. This bag has the lugs for the positive and negative output cables. Has dead front covers if you're going to use fuses instead of breakers. Fuses are a little bit wider than a breaker, and so it'll only hold, I think, 4 or maybe 3 fuses if you're using fuses. We're using breakers. Now it also comes with 2 separate bus bars for your positive lead. This is for if you're using fuses. This is for if you're using breakers. Now, as I said, you can split this in half and have 2 separate systems, 2 separate positives going out. So what we're going to do is set this up for our system. All right, we're going to take our bus bar and a lug and use the little lock washer and screw. Tighten this down real good. They say that you tighten everything down and then come back in an hour and tighten it again. But we're going to do both of these, because one we're going to use for our surge protection device, and the other we're going to use for our positive out to our charge controller. Okay, now you got a bus bar. Now next thing, because I'm going to use 3 breakers in this, I'm going to remove one of these spacer thingies. Okay, to set this up, you want these tabs pointing down. Take your breaker with on up, and you put the tab down into this positive, and then you tighten it. Just tight enough to hold it. I'm going to do that with all of these breakers. Make sure you have like I said, the yellow tab goes down. And then you just put these metal tabs into the breaker and tighten it up. So we got 3 strings, 3 breakers. Put that down in there. Make sure that's seated nice, and then crank it down. Alright, now you got 3 breakers with a bus bar sticking out the top. Now the reason I do this all up front without setting it in there is because now we need to line it up with this hole. We're going to hang these breakers off of this rail. To do that, you just pull these tabs out and it kind of locks on there, and then we'll move this dead front and sort of orient it so that this closes nicely like that. And then you just push these yellow tabs, you're locked on. Now you'll bring your positive leads from your solar panel strings and connect them into here. tighten this string, the screw down, and you'll bring your negatives in from your solar panel strings and you'll connect them to this common negative bar. And then your main positive out will go from here and your main negative out will go from there. Okay, so now our breakers are in and our bus bar is in. Next thing I want to do is add a surge protection device. Very important when you're wiring all this stuff together. This is a 300 volt SPD, also from Midnite Solar. If your array gets zapped by lightning or something gets shorted out, you want this thing to eat it, not your inverter, not your batteries. And that's what this is for. Okay. Positive wire, negative wire, ground wire. All of the voltage combined passes through this, and if anything shorts, this thing toasts. And you can tell it's working because it has a blue LED. Once there's power to the system, you'll be able to look at it and see a blue LED. This one is made first quarter 2018, so it's brand new. Now we're going to be bringing in our solar leads from our solar panels into the bottom here through strain reliefs, and we're going to be going out to our charge controller through here. So we're going to install this SPD here. So we got to take this knockout, get this knockout out of here. Just like take that out. And we want to bend that a little bit. And then bend that a little bit. And then just kind of work it back and forth. And you can just take it right out. This comes with a lock washer, a rubber gasket, and a little piece of what I think is heat shrink. So we're going to feed our wires in. Actually, you want to put your washer on. Like that. Put your wires in. Alright. Now ultimately you want these leads to end up being as short as possible. So we're going to connect this ground to this ground bar first. And so I'm going to connect it to this very bottom one here because that'll be the shortest cable, kind of like that. So cut off a piece here. And I'm going to put that in this first hole. Tighten down. Now, connect the positive. I'm going to run this along the side here. Keep it out of the way, up to this positive terminal here. So I need about that much. Okay, our positive is hooked to here. Now we need to hook our negative to this negative bus bar. And I'm going to run this same way underneath here. Kind of keep it all out of the way. And then I'm going to put it in that terminal there, so cut it here. Right there. hard to see, but okay, everything's connected. Our surge protection is connected to our positive common bus and our negative common bus and grounded here. Got our 3 breakers. Next thing, I'm going to put these strain reliefs in here to run our solar panel wires in and our main out at the bottom. Alright, I got these knocked out and I got these strain reliefs that we're going to use. I'm just going to temporarily put them in here so they don't get lost. These have 2 holes, one for positive, one for negative, for the 10 gauge solar PV wire that will be coming in from each string. I'll tighten these down and everything once we get everything wired up. And this one's a 3/4 inch strain relief. I need to get a lock nut for it though, they didn't send me one. But that'll fit in there. And then our main power to the charge controllers will come out of there. And that's all there is to it. That's how you set up a combiner box right out of the box and get it ready to wire up your array. Okay, it's the next day. That's why I'm dressed differently. We're shooting these videos and as we build this whole system, and so that's why clips will be kind of out of order or whatever. I'm just going to assemble them all into a video, into each video. But I wanted to show you the combiner box installed. I'm in the process of installing it. I have this last string to wire up and then it'll be all ready. So I want to show you what we're looking at here. Okay, each of these strain reliefs is 1 string of 3 panels wired together in series. So we have 1 positive and 1 negative coming in for each one of these. The negative goes to the negative bus bar. The positive goes to a breaker. All of the positives combine together with this combined bus bar, and then our main positive out goes up to the inverter, power center, charge controllers, and all of that. This is our SPD that we just wired, and all of our panels are bonded together with a common ground wire, and that ground wire ends up coming in here. I'm just using a piece of wire that I had, that's why it's not green or bare. And it gets connected to the common ground bus bar. And when we're finished wiring this up, we'll have 1 ground wire coming out that will go to a ground rod in the dirt. So right now I have to finish wiring up the 3rd string of panels, and this one will be finished. In our video on batteries where we talked about watts, amps, volts, resistance, and things like that, I didn't touch on voltage drop, which is a big issue when you're trying to push a voltage over a long distance, especially when you're running DC power. Our panels are 130 feet from our battery bank and our charge controllers, because this is the only place that gets the most amount of sun during the day, and so we had to figure out what's the trade-off there, and this is the best place to put them. They are closer to the batteries than our other system was. Actually, it's half the distance, but we did size it for the voltage drop. Ideally, you want 3% or less voltage drop from point A to point B, and that's why we chose. We're using number 4 or 4 gauge stranded copper welding wire, which is not cheap, but you can see it's got a lot of strands in there, and that helps to minimize the voltage drop from resistance between here and there. So I'm planning to have these 3, each string of these 3 panels are wired in series, and remember, when you wire in series, you're increasing voltage and the amps stay the same. Each panel puts out about 35 volts at around 8 amps in peak sun, and so wiring these together in series, we're going to be in the mid 90 volts at 8 amps. And so 90 volts pushing through this wire up there, we'll have about 3% voltage drop. 95 volts, I mean, we'll end up about 90 to 92 volts, and that should be fine. Okay, now I'm going to talk about the connection and the cables for each solar panel and how you wire those together. Again, we're wiring 3 in series. A solar panel comes with one of 2 types of connectors. There's an MC4 type and there's an H4 type, Infinal type. You need to know which type of connectors your panels have so that you can buy the right kind of connectors to make your leads that go from your string to your combiner box. You don't ever want to cut the ends off of a panel because that'll just immediately void your warranty. So get yourself some number 10 PV wire and get ready to make some cables. Each panel has a positive and a negative, and they look like this. This is the H4 type I was talking about. And so we connect each panel to each other, negative to positive, and then at the end of each we have a positive and a negative. And we make connector cables to bring that positive and negative into our combiner box. And so I'm going to show you kind of how I make my little connector cables. All right, now there are male connectors and female connectors, and you're going to want one of these tools. This is like a little wrench key thing. It has multiple purposes. You can use these prongs to disconnect your connectors. There's a little wrench to tighten the connector down. This is a positive connector. This is a negative connector. Male, female, they go together. So first we're going to do this one, and each one of these has a different little connector pin thing. Okay, so the end that the wire goes in, there's like a little inspection hole here, so you can see the wire when it goes in. I'm going to take your wire and measure from the tip of the conductor to that little rib. And they make fancy crimpers and all that other stuff for this, but you don't need it. All you need is a regular pair of wire cutter crimpers. So I'm going to mark where that conductor is going to end, and then I'm going to strip that wire. Don't want to cut the conductors. Okay. And then you put that on there, and you can look through that tiny little hole and you can see the copper, and that's what you want. You don't want to strip too much off. Then you take your crimpers and kind of put it in the middle there and just mash it. Okay, now it's crimped on. Now you take your connector and unscrew this nut, put the nut on. This has a little sleeve, comes out with a rubber sealer, like a washer. That goes in there too. Take this end and you just push on it until it clicks, like that. Then you match these little teeth up. And then screw on the nut. And that's why, this is why you need the this tool, because this is pretty hard to screw on. And that just fits on there like that. Ideally you have 2 tools. This hole here will go on this part, but I only have 1 tool, so I'm using good old-fashioned pliers. Just be careful not to you know, bite it too much. Hold on to that, and then you can just now this tool has an open end, so once you get to the right amount of torque, it's going to spread open and kind of click like that. That's when you know it's done. And there you have a male connector, a positive connector. You do the same thing with the female ones. Now this is going to go to that negative of that string, and the other end I'm going to pull into the combiner box and connect it to that bus bar. Now I label every one of my cables just so I know what goes where, because nothing is connected right now. I'm just running the cables and there's a lot of them, so you don't want to get confused. So this is PV1 S3 for string 3 minus, negative. So the other one I'll use red tape and I'll know that that's the positive. Okay, this is the other end of the connector I just made. So it only goes to that panel, which is pretty easy. So I just want to make sure I got enough. That looks good. We'll give it a little more. Cut it. Now I'm going to cut about 1/4 inch of the insulation off. Put it up through the strain relief. All right, now I'm going to label this end of it. The reason I'm doing this is because when we move this entire array to our house, these are all cut to the right length. I want to make sure I use the right cables with the right panels. Plus it's just good practice. PV1 S3 minus. All right. Now we're just going to kind of make this as neat as we can. Put it in this next spot. Crank her down. All right. Now we'll do the positive up to this third breaker, and this box will be done. Okay, this is the positive, and it only has to go here, so I'm just making a jumper cable, because again, don't cut these. So I got it fed through here. It's going to go into my breaker. Right there. Give it a little bit of extra. Where's my screwdriver? Crank this down. That's good. Now we can tighten these nuts, which makes it so if any of these get yanked on, it doesn't pull these out. That's what these strain reliefs are for. Disclaimer, I'm not an electrician. I'm not a licensed solar installer or any of that engineering genius guru stuff. I'm just a dude who figured this stuff out by watching YouTube videos and reading forum posts, and if I can do this, you can figure it out too. I just wanted to make a series of videos that would hopefully help you do that. That's what you get.